Hi everyone, so today's video lecture is going to be over statistics. So through the course of your research this summer, you're going to be working with a variety of data sets, and our goal at the end of this lecture is to give you some of the tool sets that you might need to analyze the data sets and also prove that you're observing something that's statistically significant. So by the end of this lecture, what you should know or have reviewed is how to calculate mean, median, mode, range, and variance, how to interpret a normal distribution curve, and how to perform a z-test versus a t-test, and when you should perform either or. And so these three things will be really helpful for your pop quiz tomorrow. So if at the end of this lecture you know how to do these three bullets, you should be all set. So first we're going to review by letting you calculate what the mean, median, mode, range, and variance of this data set. I know many of you have done this before, but I'm just going to briefly go over how you would do it for each one. And then on the next slide I'll give you answers. So to calculate the mean for a data set, you sum up all the numbers together and then divide by the total. So in this data set, I believe we have 9 numbers. So you would add them all together and then divide by 9. In the median, to calculate that, you would rank all the numbers in order from lowest to highest, and then you would pick the number in the middle. And so if you have an even number of numbers, you would take the middle two numbers and divide that by 2. The mode is the most frequently occurring value in a data set, and the range is the max number in the data set minus the min. And finally, the variance. So the variance is probably the toughest of all of this. The variance tells you the spread of your data set. So how widely do your numbers differ from each other? And the way you calculate the variance is by taking each number, subtracting the mean, and squaring that difference, and summing that over the entire data set. And so go ahead and try and do this on your own, and then pause the video, do whatever you need to do. And then on the next slide, I'll tell you the answer so you can check what you've done. So here we have the mean is 6.1, the median was 4, the mode was 2, the range was 19, and the variance was 40.9. So I don't have it on here, but to calculate the standard deviation of this data set, you would actually divide by, you would actually take the square root of the variance. Okay, so some of you may be familiar with this curve. So this is a normal distribution curve, or what's often called a bell curve. And so, or a standard normal distribution. So in a standard normal distribution curve, the mean is always 0 and the standard deviation is 1. But you can always have a curve that has a mean of 5 and a standard deviation of 10. It'll just be centered at a different point according to the mean and maybe be wider or more narrow. So if you have a distribution with a larger standard deviation, it will be wider, and if it's more narrow, if it's a smaller standard deviation, the curve will become more narrow. So what's important to know about the normal distribution curve is that the area under the curve sums up to 1. And so here at the bottom we have the cumulative percentile, so you can see it goes from 0 to 99.9%, all the way up to 1. And this cumulative percentile is important because it tells you where your data point lies within the rest of the data set. So for example, if you know you scored better than 95% of the people in your class on a test, that means that, like here on the curve, these are all the people that scored higher than you, and here are all the people that scored lower than you. And so what's also important to know is what these sigmas mean. So when we talk about our data set, we'll often talk about the spread, or the sigma, which is the standard deviation of the data. And these sigmas are really helpful for helping us figure out how to determine outliers. So if you have a value that's maybe 2 standard deviations above or below the mean, that's usually a signal that you have an outlier in your data set. Maybe suddenly the temperature in your experiment spiked, or maybe there's something worth investigating further. You have to repeat that experiment. So a lot of times people will use standard deviation to flag outliers in their experimental data sets. And so at the bottom I have the formula for the probability density function for a normal distribution, and also the formula for a z-score. And so we'll talk a little bit more next about what z-values usually mean. So this is a standard normal probability table. So in this table, the entry on the left and on the top helps you figure out what probability corresponds to a certain z-value. So for example, if I had a z-value of -2.45, I would come here negative 2.4, go to the column of 0.05, and I would see 0.0071. That's my probability. So 0.7% of something happening. And so this is a one-tailed z-table. And so what that means is that these values are corresponding to only one side of the normal distribution curve. So I know it's a little bit confusing, so we'll go through a practice problem on how you can use this z-score to help you interpret your data. So we know that the grades on a nanomanufacturing course final are normally distributed with a mean of 73.08 and a sigma of 6. Bob scored a 78 on the exam, and so we want to figure out what his z-score is. What percentage of people did he score higher than? So we can go back to our z formula, and we know that he scored a 78. So we would do 78 minus the mean divided by sigma. And so when we do that, what we get is 0.82. And so we'd go back to our z-table, and we see that we have 0.8. Then we go up here, it's 2. So then he scored higher than 79% of the people in his class. And so these values are called p-values. His p-value is 79%. So next we'll talk about how we use these distribution curves to do hypothesis testing. And so when we do hypothesis testing, we first define a null hypothesis. So that's the expected state of affairs, what you think is going to happen. The alternative hypothesis, which is the opposite of what you think will happen. The significance level, which is how confident you want to be in your results. So if I want to be 95% confident, or I want to be 99.9% confidence, that's what the significant level helps us determine. We then calculate the critical value for our data and then compare the critical value to the significance level. So to give you a better idea of these steps, we'll go through a practice problem. So a nascent student believes she can repeatedly produce nanoshapes that are 7.5 nanometers across. We would like to test this hypothesis, and so we get a sample of 100 nanoshapes and get a mean of 7.55 and a standard deviation of 1. So our null hypothesis is that the mean is 7.5, and the alternative hypothesis is that the mean is not 7.5, and we want to be 95% confident, so we're defining our significant level of an alpha equals 0.05. So we first calculate the critical value for our data. So you might notice that here in this z-score value, we have a square root of n term in the denominator. And we're using this because in this z-score calculation, we're calculating the sample mean. So this is telling us what the sample variance is in terms of the population variance. And so, here, when we calculate the z-score, we use our sample mean, which is 7.55, subtract 7.5 mean, and divide by sigma, which is 1, divided by the square root of n, which was 100 samples. And so we get a z-score of negative 0.5. And so then we compare this negative 0.5 value to what the p-value is for significance level of 0.05. So here we have a significance level of 0.05. So we go to this two-tailed table, and we found is that, so for a two-tailed table, that means we have to divide 0.05 by 2. So we go here. This is 0.025. We look in the corresponding z-score is negative 1.96. And so we know that if our z-value falls outside this range of negative 1.96 to 1.96, then we can fail to reject the null hypothesis. And so we failed to reject the null hypothesis because our z-score was negative 0.5. Okay, if you had trouble following through that, or if you have questions about what's a two-tailed table versus a one-tailed table, keep that in your head and we can talk about it in class tomorrow. And so the last thing I want to talk about today is a t-test. And so usually you perform a t-test when your sample size is less than 30. So t-test basically taking into account the fact that you have a smaller sample size, and so use a different table. And so to do a t-test, you have to calculate the degrees of freedom, but pretty much everything else stays the same. So for example, if I had 9 samples, my degrees of freedom would be 9 minus 1. And so I would look at this entry in the t table. If I had a significance level of 0.05, I would then look at this 0.05 value and see that this is my t-score, 1.833. And that concludes our statistics lecture. If you have any questions, keep them for class tomorrow, and don't forget to go over the review questions that were at the beginning of this PowerPoint, and you'll be all set.